set and track. Track circuit indication. Route is not set and track relay in pickup condition. When the route is not set and track relay is picked up, there will be no illumination on track circuit strips. Individual point operation indication. Normal to reverse indication. Press Common Point button WWN along with the Concerned Point button WN simultaneously and release to operate point from normal to reverse. Emergency point operation indication. Normal to reverse indication. When the point zone track circuit fails, after ensuring non-occupation of point track circuits, break the seal on disk beneath of Emergency Point Operation button EWN and turn the disk to free the EWN. Press Emergency Common Point button EWN along with the Concerned Point button EWN and release to operate point from normal to reverse position. Normal steady red indication disappears. Reverse red indication flashes during operation and becomes steady after the operation. Point out of correspondence with reverse control. When point control changes to reverse with point remaining in normal, the reverse white indications as per control flashes and normal red indication on only one strip flashes as per point position. Main signal clearance indication for diversion. Setting route and overlap. When concerned signal button GN and route button UN are pressed simultaneously and released, the route and overlap are set. In route relay interlocking, all the required points in route and overlap are set automatically as required. In panel interlocking, before pressing the concerned signal button GN and route button UN, points in route, overlap and in isolation are required to be operated individually to the required position. Main signal clearance indication for straight road. Setting route and overlap. Press the concerned signal button GN and route button UN simultaneously and release. The route and overlap are set, while strip indication appears on track falling in route and overlap. For points falling in the route, overlap and isolation, the indication shall be white steady strip indication along with dot indication. Introducing semi-automatic signal and reintroduction of manual control. Introduction of automatic signal working. Press GN and AGGN buttons together and release after the signal is taken off for main line. A marker on signal post is lit and A marker indication appears on signal demarcation. If A marker lamp on signal post is fused, then A marker indication starts flashing on signal demarcation. It becomes steady when the lamp is replaced. Shunt signal clearance for diversion road indication. Setting route excluding overlap. When the concerned shunt signal button SHGN and route buttons UN are pressed simultaneously and released, route is set. During this operation, points get operated automatically if they are not in required position. When points in route get locked, steady white dot or spot indications appear along with point strip indication.
Shunt signal clearance straight route indication. Setting route with no overlap. Press and release the concerned SHGN and UN buttons simultaneously. The route is set with no overlap. During this operation, points get operated automatically before getting locked if they are not in normal. When points in route get locked, white dot indications is lit in a steady state. Calling on signal indication. Route setting and locking.
After the train occupation of calling on signal approach track circuit, press signal button GN along with calling on signal button COGGN. Keep signal button GN pressed and release calling on signal button COGGN and press concerned route button UN and then release both GN and UN buttons. The calling on signal route gets set and locked. Calling on signal approach timer starts to operate. White approach timer spot indication starts flashing at the signal demarcation on the panel. Route lock white indication appears in route except berthing track and overlap. Automatic route release with train passage. On aspect signal indication. When the train enters the signaled route and on occupation of first control track circuit, the signal goes to on aspect. The first control track circuit displays red on the panel. The indication on signal demarcation changes to red. Manual route release in emergency. On aspect signal indication. Signal button GN and emergency signal button EGGN buttons are simultaneously pressed and released to replace the cleared signal to on aspect. The signal indication changes from green or yellow to red on the signal demarcation of the panel. Individual subroute release in emergency. Route section release or subroute release. The authorized signal staff has to insert the EUYN key on panel and turn. For route selection, release, press the nominated button having blue with white dot color and emergency subroute cancellation button EUYN simultaneously and release. The particular route section gets released. Manual overlap release. Press overlap release button OYN along with concerned route button UN and release. Overlap white illumination disappears. Note: overlap can be released after release of the last route section. Warning on blank signal. A yellow indication appears at the top of panel and also buzzer sounds. After noticing the signal failure, press GXYN button to stop the buzzer. The visual indication remains till the signal lamp is replaced. The yellow indication disappears after the fused signal lamp is replaced. Warning on point failure detection. A yellow indication appears at the top of the panel and also a buzzer sounds. After noticing the point failure, press W, X, Y, N button to stop the buzzer. The visual indication remains till the point detection is restored. The yellow indication disappears after the point detection is restored. Button stuck in pressed condition. If any of the button on the control panel is stuck up in pressed condition, this indication appears along with the buzzer. No manual operation is possible on the panel in this condition. This indication along with the buzzer continues till the fault is rectified. Blocks are generally used for terminating the wiring of various relay groups. Tag block consists of tag pins on both sides of the block. Each tag pin has continuity from one side to the other side of the block. Wires coming from relay groups are terminated on one side of the tag block. Circuit wiring is done on other side of the tag block. That is, interwiring between one group to another group and to the external connections such as panel, external cables is done at the tag blocks by using jumper wires. 0.6 mm diameter jumper wires are used for all circuits and 1 mm diameter jumper wires are used for point control and signal lamp circuits. More than 2 wires shall not be terminated on one end of tag block pin. The counting of tag block pins is done from the wider end of tag block towards thin end. The coil connections 91 and 92 will be nearer for testing as shown. In small installations, the tag blocks are provided in rear of relay rack. In case of major yards, the tag blocks are fixed on a separate row of racks called as intermediate distribution frame, that is, IDF, numbered according to the relay rack numbering. 60 cores and 40 cores indoor cables are used to make the connection between the relay groups and tag blocks. On one IDF pillar, maximum 10 tag blocks can be connected. The tag blocks fixed in the control panel or at the cable termination board are called as main distribution frame, that is, MDF. The arrangement as a whole gives a neat appearance and renders alteration to wirings, localization of faults, etc. Easy with minimum disturbance to the working installation. All the connections to terminal boards, IDF relay groups are done by soldering. The solder joints have proved to be satisfactory in practice. Tag blocks enables easy fault localization as the test voltages of the circuits are measured on pins of the tag block, conveniently facilitating quick restoration of faults, if any. Different types of tag blocks. There are 3 types of tag blocks available. They are 200-way tag block, 160-way tag block and 96-way tag block. One tag block of 200 terminals can accommodate one number of major group or 2 numbers of minor groups or 5 numbers of mini groups. One tag block of 160 terminals is sufficient for 4 mini groups. 96-way tag block is normally connected inside the control panel at the cable termination board. It can accommodate wiring of 6 numbers of dominoes of control panel. 100-pin tag blocks are used with ABB relay groups. Numbering will start from the concerned rack side of tag block. The counting will be in increasing order from the rear towards the front as shown above. The numbering scheme of a 200-way tag block is generally used for one major groups is shown.
The numbering will start from 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. 3 to 93, 4 to 94, 5 to 95, 6 to 96, 7 to 97, 8 to 98, 9 to 99, 10 to 100.
Similarly, the numbering will start from 101 to 200 tag pins. The numbering scheme of a 200-way tag block is generally used for two minor groups is shown.
The numbering will start from 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. 3 to 93, 4 to 94, 5 to 95, 6 to 96, 7 to 97, 8 to 98, 9 to 99, 10 to 100.
Similarly, the counting starts for second minor group. The numbering scheme of a 200-way tag block is generally used for 5 mini groups is shown.
The numbering will start from 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. 3, 13, 23, 33, 43, 53, 63, 73, 83, 93. 4, 14, 24, 34, 44, 54, 64, 74, 84, 94.
Similarly, the counting starts for second, third, fourth, and fifth mini groups. The numbering scheme of a 160-way tag block is generally used for 4 mini groups is shown.
The numbering will start from 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. 3, 13, 23, 33, 43, 53, 63, 73, 83, 93.
Similarly, the counting starts for second, third, and fourth mini groups. The numbering scheme of a 96-way tag block is shown.
The numbering will start from 1, 11, 21, 31, 41, 51, 2, 12, 22, 32, 42, 52, 3, 13, 23, 33, 43, 53, 4, 14, 24, 34, 44, 54.
100-pin tag block used for ABB relay groups. Counting is shown in picture. The numbering will start from
A1, 11, 21, 31, 41, 51, 61, 71, 81. B1. A2, 12, 22, 32, 42, 52, 62, 72, 82. B2.
Similarly, the counting repeated for second, third, fourth, and fifth for ABB relay groups. Iron made of length 65 by 65 mm. Iron angle with 6 mm thickness frame and its height is 2087 mm. The frame assembly size for 4 racks is of length 2087 mm and breadth 2596 mm. The frame assembly size for 3 racks is of length 2087 mm and breadth is 1962 mm. The frame assembly size for 2 racks is of length 2087 mm and breadth 1328 mm. Scaffolding is erected on 75 mm pedestals with 40 mm insulator. In short, scaffolding is erected at a height of 115 mm from the ground, that is, 1 pedestal for 1 rack is provided. Relay racks are made of length 40 by 40 mm iron angle with thickness of 5 mm and its size is of length 2065 mm and breadth is 554 mm. Relay rack to relay rack gap is 80 mm. The distance from the parallel wall to the first row of relay rack should be 1.5 meters, ends 1.5 meters from wall, in between racks 1 meter to enable free movement for maintenance staff in between 2 rows of racks. In small installations, the tag blocks are provided in rear of relay rack. Proper side and back supports are provided by means of single irons from the adjoining walls. Ladders are fixed at sides and top of rack to run the cables and wiring. One relay rack can accommodate 8 rows of mini groups, that is 64 relays, maximum 9 rows with G-type fuses. 4 rows of minor groups, that is 16 numbers, 4 in each row, and G-type fuses. 4 rows of major groups, that is 8 numbers, 2 in each row, 1 points chain group and G-type fuses. Last row of the relays on the relay rack shall be at least 600 mm above floor level for easy maintenance. Relay racks have 15% of spare capacity. Relay rack shall not be earthed. In case of major yards, the tag blocks are fixed on a separate row of racks called as Intermediate Distribution Frame, IDF, numbered according to the relay rack numbering. 60 cores and 40 cores indoor cables are used to make connection between the relay groups and tag blocks. Interwiring between one group to another group and to the external connections, such as panel, external cables termination, is done at the tag blocks by using 0.6 mm diameter jumper wires. Location. Signal plan. The route section plan shows the entrance and exit buttons with their designations at their geographical location. In metal-to-metal relay interlocking system, interlocking between various signaling functions is not directly provided as in the case of other systems. For this purpose, a major yard is considered as follows: yard to zones, zones to signal routes, signal route to subroutes, subroutes to route section and overlap. In a yard, points are available in route as well as in overlap. Points in the route section will be controlled by URS, by UNS relay and points in overlaps are controlled by OVZ2URR by OVZ2UNR relay. The route sections and overlaps are the basic units for achieving the interlocking. These are required as all the relays concerned with the route, that is, point detection, point zone track circuits, route setting, route checking, route locking, sectional route release relays are provided in the route group. Number of zones is considered on the size of the yard. A way station is normally taken as one zone, and each zone will have one main GZR relay, one shunt GZR relay, and one ZDUCR relay. For each and every signal movement initiation, ZDUCR relay has to pick up. For example, in a 3-line station of single-line section with shunt signal and calling on signals on both sides, it will have about
28
signal routes, that is,
4
up-home signal routes, 3 up calling on signal routes, 3 up shunt signal routes, 3 up starter signal routes, 1 up advanced starter signal route, making it to
14
signal routes for only up direction. Similarly, there are
14
down direction signal routes are available. There are
28
signal movements for this small station, and for every signal route initiation, ZDUCR relay has to pick up. That means for a small station, ZDUCR relay will have
28
parts to pick up. Any trouble with ZDUCR circuit will affect all the movements in the yard. In case of bigger yards, to reduce the complexity of ZDUCR relay circuit and ease off with movements, it is divided into 2 or 3 zones and, if required, more zones. Division is being done as per flexibility required and not on number of signal routes. 2 zones allow 2 signal movements to be initiated simultaneously if the movements are confined to independent of zones. If any trouble with one zone, other zone movements will not be affected fully. Consider the following example. In New Delhi metal-to-metal relay interlocking system, there are 1,278 signal routes with 3 zones. At Nijamuddin metal-to-metal relay interlocking system, there are 429 signal routes with 3 zones. At Old Delhi metal-to-metal relay interlocking system, there are 1,117 signal routes with 4 zones. The entire layout is considered for the signal routes, and depending on the movements, conflicting movements, and sectional route release facility, the point zones are divided into number of subroutes. Each subroute requires one route group and will allow only one movement. Subroutes are numbered as per the number of any one point which exists in it. If 2 or more points are involved, the important or leading point number will be selected for its numbering. If there is no point, such subroute will be numbered as per the signal in case of double line, or signals in case of single line controlled by it. Subroute which includes 1 or more points are so formed by combining route sections, so that only one movement is possible over that subroute at a time. This is ensured by a common and a lone subroute locking relay, URLR, in a relay group.
For a crossover point in which two parallel movements are possible, it requires two subroutes, so that one movement in each subroute is possible simultaneously, as locking of one movement will not affect the other movement. As both parallel movements are to be locked by two separate subroute locking relays, a crossover point with parallel movements requires to be planned with two subroutes with two independent route groups. Each subroute is further divided into route sections. Each route section usually have certain specified setting of points. That is, each definite setting of points leading to a signal movement will be considered as a different route section within a subroute. The straight movement over a subroute requiring points in normal position is called A route section, and the diverging route requiring points in reverse is called B or C or D route section. A subroute can have one route section or more number of route sections. A subroute requires one route group, and each route section requires one route setting relay and one route clear checking relay. Hence, one route group relay can cater for one or maximum two route sections, as there are only two route setting relays, UNS by URS, and two route clear checking relay, DUCRS. These route sections are known as A route section and B route sections. If for any reason it requires to add one or more route sections to a subroute, extra UNS by URS and DUCR relays and mini-groups for each added route sections are to be provided outside the relay groups and to be wired accordingly, and they will be called as C route section and D route section, etc.